Hi, I'm Peter. In this tutorial I will show you the operation mode, in which Canoe is used as the execution master for your DYNA4 simulation. If you didn't watch the introduction by my colleague Susan to the joint usage of DYNA4 and Canoe, you may want to do this first. Otherwise, we are ready to go. Please start DYNA4 now, if you didn't do it already. We will use the Demo Studio project as the template for our DYNA4 and Canoe simulation project, because it has the fewest license requirements, but any DYNA4 project can be turned into a suitable Canoe simulation model. There are no specific requirements to the model. Please generate a Demo Studio project and use it as the template for your own simulation model. Just go to the File menu to create a new example project and select the Demo Studio project. Let's rename it to My Canoe Simulation and finish the dialog. Please open the newly generated project now. For controlling the simulation in Canoe, we have to prepare a Canoe configuration first. Please open your Canoe installation and create a new default configuration. To save us some time, Susan kindly prepared all the files you need for generating your Canoe configuration for DYNA4. You find them under this link. First, please copy all the provided folders and files into the subfolder user code of your newly generated DYNA4 project. We will import them in the next steps into the new Canoe configuration. Let's start with the CAPL scripts. Please go to the configuration desktop, insert a new program node to the measurement setup and use the DYNA animation control CAPL script for the configuration. This script will take care of starting DYNA animation. Next, add two new CAPL test modules to the simulation setup and reference the CAPL scripts simulation control and register user files to them. The simulation control script is required to write the correct dataset paths to the model blocks and assign the parameters. The register user files script makes sure that files like the parameter set files are known to Canoe as additional user files. Let's continue with the system variables. Please go to Environment, System Variables, and import the Animation Project Launcher and the Scenario Selection System Variables files. Now you can decide where you want to import the prepared panel or create a new DYNA4 specific desktop. Please go to Home, Panel, and add both panels that we provided for you. As long as you have no real buses configured, you have to select the simulated bus. Please save the new configuration to your user code folder, let's say, Canoe Execution Master. We are done for now with the Canoe configuration. Later we just have to assign the DYNA4 nodelayer DLL, but for this we have to prepare the model first. Let's go back to DYNA4 Studio. To prepare the DYNA4 model for the use together with Canoe, we have to edit the Simulink model and add dedicated communication ports from the Canoe MATLAB interface library. So please start MATLAB and open the Simulink model first by clicking on the Simulink icon in the toolbar. While MATLAB starts, a small note to the Canoe MATLAB interface. This interface is usually provided as an additional installer with Canoe, but DYNA4 automatically comes with a supported version, so you don't need to install anything additionally. If Canoe is used as the execution master, the DYNA4 model has to be moved to an enabled subsystem. Otherwise the simulation will directly start with the Canoe measurement, and we are not able to set different scenarios. Just add an enabled subsystem from the Simulink library and transfer the complete DYNA4 simulation model content into this subsystem. Configure the corresponding enable port to reset states when enabling. For enabling this subsystem from Canoe, we have to add a Canoe system variable input block. You can find them in the Simulink library browser in Vector Canoe, Canoe.io. Just drag and drop them into the Simulink model. Double-clicking will open the configuration dialog. When you click on Select Variable, you can select any system variables from the active Canoe configuration. Please select the Disable variable. For the correct input of the enabled subsystem, the signal must be negated. For interacting with the DYNA4 model in Canoe, we will add several in and output values. In DYNA4 you can add control signals in different ways. You can either search for the signal in the Simulink model and break the signal, or you can add a switch that allows you to switch between the custom signal and the original DYNA4 control signal. I will show you now the switch generation. Please go to DYNA4 Studio and the model perspective. In the signal source selection, you can find all the control bus signals that can be edited. They are grouped by their subcomponent. Go to the longitudinal control, right-click on any signal and edit the signal source group. Here you can select all the signals for which you want to add a switch. Let's select the acceleration pedal position and brake pedal position from the longitudinal control section. Finishing this dialog will automatically create a new switch in the switchboard of the DYNA4 Simulink model. The original control signals can either be superimposed by a scaling factor and an offset or overwritten by a custom value. Please repeat this procedure for the steering angle. The switches can be used automatically in Canoe and no additional steps are necessary. Making a vehicle output signal accessible for Canoe does not require any switch or additional model changes. Let's look at the acceleration as an example. The signals for longitudinal and lateral acceleration can be accessed directly from the vehicle bus in Simulink. Just add a bus selector and select the acceleration at the center of gravity. The acceleration is provided as a three-dimensional signal, so I'm adding a demux block to access the single directions, x, y, and z. Now, just connect them with a Canoe system variable output block from the Canoe Simulink library. We haven't defined the DYNA4 output variables in Canoe as system variables yet. Let's do that now and go back to the system variable configuration in Canoe. Use, for example, the namespace DYNA4 output. Add system variables with data type double for all three acceleration directions. Save your Canoe configuration. Now we can go back to Simulink. After double-clicking on the Canoe system variable output block, the configuration dialog will open and you can now directly access the system variables we just defined via the select variable mechanism. These are all the model adaptations we have to do in the Simulink model. Please save all the changes and go back to the project overview perspective of DYNA4 Studio. Now we are ready to export the model for the Canoe target. Add the Canoe simulation target to your list by clicking on the gear button and enabling Canoe, if you didn't do it already. To export the simulation project, click on the Export button in the Project Navigator, or right-click on your simulation project and select DYNA4 RT dataset. Here we have to add the model and the scenarios that we want to export. For this demo, we only have one each, but you could prepare and export multiple models and scenarios in one step. Now we have to select the export mode. Do not build and use existing files can be used when you exported or compiled the model via the build button once and didn't change anything in the Simulink model or just did some parameter changes. Build each model once and reuse files is the one we will choose. Even if you have multiple model data and scenarios, each selected model will only be built once. When clicking on the Next button, you come to Further Export options. The name of the exported dataset can be defined or selected here. The default name consists of the simulation project name and the prefix RT for runtime. I recommend you to leave it to default because the name is part of the path, and if the path changed, you will have to do some adjustments in the Canoe configuration. When you finish the dialog, the model will be compiled and exported as an independent project. The build procedure will take a while. As a result, we will have the model compiled as a Canoe nodelayer DLL and additional dataset files that include model and scenario parameters. As you might know already by now, that means that unless you make any changes to the Simulink model, you don't need to recompile it. If you create new scenarios or model data or you make changes to the existing ones, you can simply export more scenarios and model data files. To have everything in the same place, I recommend you to copy the RT project to the user code folder of the My Canoe Simulation project. Now we just have to reference the nodalayer DLL and the automatically generated model data system variables to our Canoe configuration. Please go back to the configuration desktop in Canoe. To assign the DLL to your configuration, just right-click on any test CAPL modules and select Configuration. In the Components section you can add the DLL that was generated during the RT export. Choose the one that is named like your simulation model. Some project-specific system variables were automatically generated. We need to import them in Canoe in the same way as before. By the way, you could even close DYNA4 MATLAB and Simulink now as they were only necessary for authoring, but not for the execution of the model. When all the steps are done, we are able to run our DYNA4 simulation in Canoe. Please start the Canoe measurement, apply a scenario and enable the DYNA4 simulation. The animation window opens automatically and you can see the vehicle moving. To control the vehicle via the signal switches, add the variables to a data window. You can find the variables in the section SingleTrack according to model name in DYNA4. Just add the enforced variable to activate the switch and the value variable to set the new value. Repeat this for all the switches you added to the model. Now you can change the variables and directly interact with the model. Let's try it out with the brake pedal position and set it to 0.5. In DYNA animation you can now see the vehicle braking and coming to a stop. Needless to say, for more comfortable control you can add the system variables to a custom panel. That's it for the operation mode in which Canoe is the execution master.
Thanks for this hands-on introduction, Peter. You now got a deeper insight into how DYNA4 and Canoe can be coupled with Canoe as the execution master. If you are interested, you may want to watch our other tutorial in which Peter explains how DYNA4 can be used as the execution master. Like in this tutorial, Peter will explain how a DYNA4 simulation model is prepared from scratch for the usage with Canoe, so you don't miss any of the important steps. However, DYNA4 is also shipped with an example project called Demo Canoe Interfacing. This project contains Canoe configurations for both execution modes as well and is ready for execution without any further preparation. You can either use the files that we provided for this tutorial or the files contained in the example project as a starting point for your own project. We hope you enjoyed this tutorial video and that you feel prepared to start your own projects in DYNA4 for the usage with Canoe. If you have any further questions, don't hesitate to contact us. Thank you for your attention.